All right, you guys, let's go ahead and continue our talk on variation. This time we're going to try our hand at an inverse variation problem. All right, so let's read the prompt first. So the maximum weight W that can be safely supported by a 2-inch by 4-inch piece of pine varies inversely with its length L. Experiments indicate that the maximum weight that a 10-foot long by 2 by 4 piece of pine can support is 500 pounds. Write a general formula relating the maximum weight W in pounds to length L in feet. Find the maximum weight W that can be safely supported by a length of 25 feet. Okay, so just like before, all right, when we did our direct variation example, we want to ask ourselves the question, what type of variation is this? All right, so remember, like I told you before, it's not a guessing game. They're going to have to tell you what type of variation you have. So when we go back and look through the problem, here's our clue right here. It says that it varies inversely. Okay, so this time we are dealing with inverse variation. Okay, now that we know that we have inverse variation, automatically I need to think about, okay, well, what is the equation that I'm going to use to relate my two variables? So for inverse variation, the model that you're going to use is y equals k over x. And the way that we read that is y varies inversely with x. Okay. So now that we've identified what type of variation we have, remember the next question we need to ask ourselves are, what is or what are my variables? All right, so I'm checking to see, okay, am I still using y and x, or are there some other variables that are in my problem? So let's take a look. So it says the maximum weight W that can be safely supported by a 2-inch by 4-inch piece of pine varies inversely with its length L. So right here in the first sentence, I see that I no longer have Y and X, but I have W and I have L. Okay, so let me go ahead and record those for us. All right, so we have W, which they tell us is the weight. Well, they actually call it maximum weight, so let me be specific. All right, and the other one that we have is L, which they tell us is the length. Okay, so now that I know my two variables, I know what type of variation I have. Remember, let's go ahead and plug those into the formula so that we have it in the right form. So they tell us that the maximum weight that can be safely supported by a 2-inch by 4-inch piece of pine varies inversely with its length L. So if I'm plugging those into my model, remember this is read y varies inversely with x. I'm going to say W equals K over L. All right, that's going to be the placement of my variables. Okay, so we have the variation, we have our variables, we put them into the equation. The next thing is that we need to solve for K. Okay. K is our constant of proportionality. So there has to be a relationship in our problem between our two variables already so that we can solve for K. So let's see if I can find a W and an L that already exists within this problem. So if we go ahead and we look at the second sentence, it says that experiments indicate that the maximum weight that a 10-foot long by 2 by 4 piece of pine can support is 500 pounds. There's my relationship. My L, or my length, would be 10 foot long. That's how long the board is. And I want to find the W that goes along with that L, and it's 500 pounds. Okay. So I know that L equals 10 feet and W equals 500 pounds. All right. So since I'm solving for k, I can go ahead and plug that in to my equation so that I can solve for it. All right. So let's do that up here. So we're going to have 500 is our W equals k over 10. All right, so since we're solving for k, remember k needs to be isolated, which means it needs to be on the side of the equation by itself. So I'm going to go ahead and cross multiply. This is like 500 over 1. So when I go to cross multiply, that gives me k equals 5,000. All right, so now I'm good. I have my k. I can go ahead and plug that into my model. Remember, that specifies it. So I know how my variables are interacting with each other, but now k tells me by how much. So my new model is W equals 5,000 over L. All right. So now let's go back to the problem to see what they actually asked us to find. All right, so when we've already written a general formula relating the maximum weight W in pounds to the length L in feet. All right, that was that equation here that we just found. All right, so if we read the last sentence in the problem, it says find the maximum weight W that can be safely supported by a length of 25 feet. All right, so they're asking us to find W, okay, when L is 25 feet. All right, well, we can do that. So they want us to find W when L equals 25 feet. Make sure I got that right. Yep. All right, so we're going to plug that in. All right, we have our model. Now we have the values that they want us to find. So we're going to say W equals 5,000 divided by 25. When I do that division, W equals 200. All right, and remember, W were being measured in pounds. All right, so that should be our answer. So let's go ahead and check it with our solutions. All right, so we did exactly what they told us to do. We found our original model. We knew that it was varying inversely, so we set it up correctly. Good. All right, we found our constant of proportionality, which was 5,000. Good. We plugged that back into the model and rearranged. And then we answered the question that they posed. So we got 200 pounds. So we're correct. Great. All right, so if we wanted to see what that problem looked like graphically, all right, it would have kind of this curve feature for us. So remember, inverse variation means as one of your variables is increasing, the other one is decreasing. So in this case, all right, the longer your board is, the less weight it can support. The shorter your board is, or the length, the more weight it can support. So like we said, our two variables, weight and length, they're varying inversely. All right. Hope this helped.